So my name is Phillip Strader. I am a project scientist with the Research Triangle Nanotech Network, but specifically I work at the Analytical Instrumentation Facility at NC State. If you're used to the Takeout Science broadcast and the usual person running it, that's Dr. Holly, who is over at Duke, and she's in the background this time. If you recognize me, I was the first guest host that we ever had on week 4 in when we were going over textiles. So my background is all in textiles. I went to NC State to study textiles for my bachelor's and graduate degree. And after that, I ended up working at AIF at NC State through the RTNN. And on a daily basis, I'm doing a lot of different testing within the AIF. I'm directly responsible for a couple of instruments that aren't necessarily useful to you guys, but I do operate some of our high-end SEMs and AFMs here. And so we have a new SEM, a tabletop one. Now, the reason that Takeout Science started was because Holly had a nice portable SEM that she could bring home. Now, we have basically the newer model, latest and greatest, and I'm gonna probably make you dizzy for a second because I'm gonna show you a picture of it. So this is the new SEM. It is Hitachi TM4000, has a couple new upgrades that Holly doesn't have on hers, but make my life a little bit easier. It has a motorized stage, so I can drive around really fast, whereas Holly gets a forearm workout while trying to turn it around. So we'll be able to go from sample to sample really quickly. All right, so this Takeout Science is also a little bit different because we're not necessarily coming in with a specific lesson that we're gonna go over. This is all about the users, and we asked you all to submit samples. I think we started asking for samples a few weeks ago. I didn't get a lot, but we got enough that really interesting stuff that we can go into, and I had to do a little bit of homework to learn about some things to teach you guys, or teach you all. All right, so I'm gonna go and start sharing my screen, and you may see, let me see if this works. There we go. So another key difference today is that we don't have a science dog, so I need to show that I do have science dogs supporting me remotely. I have a Corgi and a Greyhound at home who are missing me now that I'm working in the offices again pretty much all day. So this is a picture of them being sassy right now. So they're not doing any science right now, but they're giving me a lot of sass. So obligatory science dog picture, and we're going to get into looking at the samples on the SEM. So the two samples generally that I have today are seeds and a wasp in a wasp nest. And I'll go into some backstory on the wasp later, but we're going to start out with the seeds first. So you'll notice this software looks a little bit different from what Holly's looks to. So what Holly's looks like. So I'll go over some key differences as we go. But let me see if I need to hide this little panelist thing. Okay, so now Holly also had a light microscope in her sessions. I do not have one here with this setup, but with this microscope, we actually have an optical view of the samples that are in the microscope. So if you look at the bottom right, you can see the samples that are loaded. So this is the first sample I'm going to start with, and I'll kind of zoom in and on this specific one. And so this is an apple seed. And I think someone sent this to me already cut in half, or they had kind of opened it. And so we're going to look at that real quick, and then I'll talk about the other samples as we go. So this first sample is the apple seed. And so let's go to the outer shell really quickly. And I'm going to click auto brightness, and then we're going to focus a little bit. There we go. All right, so now I'm going to back out a little bit and going to start scanning very slowly. Zoom controls are kind of getting in the way here. All right, so we're scanning a lot slower now. So before I was scanning very fast so that I could see what I was doing with the brightness and contrast. Now we're scanning slower, which to an SEM is a lot like, taking your time reading a book. So when you read slower, you get more details. So And I have some drawings behind me that I'm going to be pointing to. And just remember, I went to textile school, not art school, so I am not a great artist. But there's all kinds of different seeds, but in almost all seeds, you have differences, or you have these three main structures. So you have the epiderm, or the spermaderm, or sometimes they call it the endosperm. The epiderm is kind of like your epidermis, so your outer layer. The spermaderm is the layer just inside, which is kind of like the protective outer hull. And then on the inside, you'll have the endosperm, which is the inner hull. And then on the inside, depending on what stage the seed is in, that's where the embryo is and where all the other things that make up what that seed organism will grow up from starts as. So on almost any seed, the outside's going to be very, very stiff and very strong. So let's go zoom in to that real quick. Let's see how thick this one is. Okay, so we're focusing. Now let's scan a little bit slower. All right, so the magnification we're at, you can see right here, we're at 250 larger times than real life. And we have a scale bar down here where the distance from this dash to this dash is 200 microns. So if I were to measure that, that'd be about that distance, maybe a little less than 0.2 millimeters thick. So we see there's all kinds of different layers in there. So let's go a little bit faster. And now let's look on the inside. So this is the actual inside part of the seed, which is where the organism, I guess, would be forming. Now, usually we just toss apple seeds, but when I was a kid, anytime I ate an orange or an apple, I think I would go and try and put it into the ground and hope it grows. It is possible to make apple seeds and orange seeds germinate, and there's all kinds of YouTube videos on it, but it's very difficult. But it's just crazy how the inside looks. It's almost got like this porous structure. Now, some parts of the endosperm actually serve to store the food that the embryo survives on. And I think in apple seed, the case is that it's eating starch. So we're at 150x magnification. It looks really neat. Now we're gonna go just to the inside and see what this looks like. So that's really great to me. You see all these kinds of pores. I'm not a seed expert. This is actually the first time that I've actually looked at this in great depth. But today I wanted to kind of go over the difference, like try to see the differences between an apple seed and the next seed that we'll be looking at. Alrighty, so let's go back to scanning fast, and I'm gonna try to go look at what would be kind of the tip of the apple seed, which, you know, if you've seen an apple seed, it kind of has this shape. This is a drawing of a flax seed, but I mean, it's pretty much the same shape where you have the body and then you have this little tip here. Let's go see what that looks like. So as that's scanning, you know, pay attention to the different layers here. It's hard for me to tell, but I would think that this is an epiderm, and this would be the endosperm, and then this would be the inside of the seed, which would be where the multicellular organism would be forming that would eventually grow into a tree or whatever other plant you're using. Now, I didn't notice this before, so I'm going to zoom into that. See what that is. There's all kinds of crazy textures in there. To me, an apple seed almost looks like wood to the naked eye, at least when you're looking at it if you were to break one open. So it's interesting to see what it looks like inside. So very crazy. I always wondered why you shouldn't eat apple seeds, and I looked it up, and it's not that they actually contain cyanide. It's that they have a chemical in there that when the shell is damaged and even digested, it turns into cyanide, and that's why you should always spit out your apple seeds and hope they grow into trees instead of eating them. I'm sure no one here is getting any ideas for that. All right, so now we've looked at that, let's go look at a flax seed. So we're all familiar with apples probably, but we may not be as familiar with flax. It's a common, or it's becoming more common to eat it, but flax has been around for a very long time. It's a plant that can produce all kinds of things from it. You can get fiber from it to create linens and textiles. So there's my wheelhouse. You can also, it's more lately being used commonly to make food. So you can extract oil from them. They're very oily. And so I think they're like 40 to 50% oil, and you can extract that to make cooking oils, and then other, even like table varnish. And what a user, and it's the name on the envelope says Rebecca Dravenstadt, but I think the person tuning in today is Corin. So I'm going to assume that you guys are you both are the same. So let me see if I can see myself so I can make sure you guys are seeing this. So Rebecca or Corinne sent me a bunch of flax seeds, and let me know if in chat if y'all can't see this okay, and I can send these pictures in an email later. But even though it looks kind of dark right now, I believe these are yellow, and there are two types of flax seeds. There are brown flax seeds and yellow flax seeds. And the brown ones are usually not used to make food with. Those are the ones that are usually made to make textiles or oils for varnish, the strong stuff that you wouldn't want to eat. And so these are the yellow ones. And I'm going to pose the question that the person that sent this sent with me, which is that they are hoping to learn what makes them stick to everything, even stainless steel. So as we move along, let me know or start thinking about that. So let me minimize that. So let's move over to this one. I put a few different ones on here, and let me minimize this again. Whoops. And I'm zoomed in a little bit more where you can kind of see I have one seed here, another seed, and then what I did was I tried to take a razor blade and create a cross section of one of the seeds. So right now we're looking at one that's relatively intact, and you'll notice that that's kind of shiny. All of these samples are coated with gold to make it more conductive for imaging with an SEM. And so now let's look at this whole seed. All right. If I haven't mentioned already, flaxseed oil is also called linseed oil. There's a Norwegian cooking show that I sometimes watch. They used linseed oil a lot to cook with. All right, so let's start going slow. And we're not at any crazy magnification right now. We're at just about 25x. You could do this with an optical microscope, but I wanted to give you an idea of just the size before we start zooming in onto it. Now, my observation about this is that it's very smooth, and when I look at these in real life, I mean, they're very shiny. And I noticed they weren't sticky to me, and I never have had flax seeds just empty or just like this to myself. So this is my first time, and my first observation was, well, they're not sticky, they're not sticking to anything. So what I wanted to see if there was like a structure that was making them sticky first, and from just this very low magnification, it doesn't look like anything is sticking out to me. We'll zoom in just a little bit more, and then I'll go back to slow scan. So we're back at 250x, and even zooming in, it's very smooth. I mean, there's particles on the surface, but that's probably just particles from other plants, or just, if I touched it with a finger, I could have got stuff on it. But we start to see just a little bit of scratches and stuff, but otherwise that looks pretty strong. And again, the purpose of that outer shell is to protect the contents within the seed. So it has to be strong. So that would explain why it looks really smooth and very strong, kind of like a turtle shell almost. Now, I'm going to go over to the cross section, and I found a link with a really good cross section of a flaxseed that that they went through a lot more trouble to make a clean cross section. Making cross sections for SEM is very difficult. You would think you can just cut with scissors or take a razor blade and chop it. Both of those cause a lot of force and pinching action, which actually cause like damage to happen. So there are microscopists that, you know, if you need a very clean cross section and you wanted to look at there's even sub layers within the different layers of like the shell. And if you wanted to see all of those, you'd have to make a very, very clean cross section with very sophisticated techniques to be able to do that. So I found a link and I'll try to share that later, but let's look at the inside of this sample just by looking at it or cutting it with a blade. All right, so let's back out just a little bit. And sure, let's do, I can even rotate this a little bit. Well, no point in doing that. All right, so we'll start scanning slower so we can get a nice low magnification image. We're at about 40x of the cross section of one of these flax seeds. So what now sticks out to me is you can see that the inside has a lot of texture to it, whereas that outside shell is relatively smooth, and we'll zoom in a little bit to see if it really is in just a second. But this inside has a lot of texture, and what I didn't expect is for it to kind of have this great big divide in the middle of it where it looks like it's cracked. So I wonder if that's just what the natural structure of it is, but we'll zoom in just a little bit more to the inside. So this is the inside of the shell. So given that flax seeds are at least 40 to 50% oil, and you usually press oil out of this, I mean, it's possible that this is just an emulsion of the oil that's kind of stayed together inside, because we haven't pressed anything out of this. But if you look up, if you want to get really into the science of it, there are some people that have made, the only other SEM images that I can find of flax seeds on the internet, at least last night, just searching for an hour or so, were some researchers that have been trying to make nano emulsions from different flaxseed oils or linseed oils. And so their images looked a lot like this, but just higher magnification. So we're at like 250x. They were making stuff that was very, very small. And I even think at the College of Natural Resources here at NC State, there is somebody trying to basically make like edible plastic film out of flaxseed oil. And so what they did is actually press the oil out of the seeds and then try to extrude it into a film. So we're all used to like saran wrap, right? Or we'll just call it plastic wrap or cling wrap, something like that. We're all used to that. Like if you have like a extra food, you would wrap it up in that. So what if you could make something like this, wrap it up, and you can either eat it or compost it later. So there's so many crazy uses for flaxseed that I didn't know about before I started. All right, so before I actually saw these today. Let's go back to fast. All right, so now let's zoom in on the outside here, and just wanted to quickly show this. And what it looks like to me on the edge, like as we look down the face of this cross section, it almost looks like that stuff is coming out. Now, we didn't see this as much on the flat one, but it looks like from the force of me cutting the seed in half, it probably caused fractures going down the length, and it looks like that interior contents was coming out. So I thought that was a cool shot. It almost looks like lava coming out of a crag in the earth. It's crazy. All right, so let's go back to the initial question that Rebecca or Corinne had, which was, we want to learn what makes them stick to everything. So I didn't notice they were sticky when I touched them. And you know, when I first thought about it, it was like, maybe this oil gets out and it gets sticky. Well, apparently there is, well, first, there's a lot of fiber in flaxseed, so it's very good for digestive health. There is insoluble fiber, which will not dissolve in water. Insoluble means won't dissolve. And then you have soluble fiber, which will dissolve in water. And so about 6 to 10% of the fiber content of flax seeds is actually in its epiderm layer, and it's called mucilage. So everything that I could find online showed that people get frustrated with flax seeds getting sticky when they're wet. So that must mean that the mucilage is what is basically dissolving when you put it in water, and it's probably creating an oil or some type of film, almost like an adhesive on the outside. I'm just checking the chat real quick. Oh yeah, you need to make a, yeah. Oh, Maud, you sent a question to me. I think you meant to send that to Corin. So yeah, maybe that's why it gets sticky. And actually, when I started looking at it, I started going into basically looking into what the science of what people do with things is. There was all kinds of papers out there about how people actually try to extract the mucilage out of it to create goods or things like that. So that's my theory on the answer to your question, or at least that's what I found on the internet. All right, so that's the flax seeds. Actually, before I move on, we're not going to get too deep into seeds today, but with flax seeds, the flax flower actually has its own flower, and then it'll have like this pod of seeds, and the seeds will basically explode and spread everywhere. The closest analog I can think to that is like a dandelion. You know, we've all seen those dandelions that you blow and the seeds go everywhere. Apparently, that's the exact thing that happens with flax as well. So it basically just pops. There's pressure in it, and it causes the seeds to go everywhere. I've heard it's not as exciting as you think when you hear an explosion, but it sounds cool. But this is drastically different from what the seeds that we commonly see with like apples and oranges, where we eat the apple or the apple falls off the tree, and or some type of omnivore eats or herbivore eats the fruit, and then it passes through their digestive system and then gets into the ground and then grows more. So it's a little bit different because the fruit doesn't have to be sweet. If you're an omnivore and herbivore, you just want to eat fruit, you want to eat something sweet. So that's why fruit has to be attractive in taste. Whereas for flaxseed, we've kind of forced it into using its seeds as food. At least that's how I feel about it. All right, so let's back out. And now before I get to the next one, I'm gonna get out a glove just so I'm not touching this, because I want to preserve it actually. But this next one I received was just labeled as a wasp nest. So let me pull up my camera so that I can see myself and make sure that you guys can see what I'm looking at here. All right, so this is just a piece of a wasp nest that was sent to me. Now, I just assumed it was just a piece that someone had found either on the ground or under their gutter or something like that. And I can't just put this whole thing in. So what I did was I cut a section of paper from it, of it out, and put it in the SEM. But when I was doing that, I also noticed a little head sticking out one of these holes. So apparently, I guess this had been exterminated or sprayed on, and there was a little wasp nest. And I'll admit I got scared because I'm like, I poked it, like I did not want that thing to come out and get me, because I've been stung by a wasp before and it definitely hurts. So we'll go a little bit more into that, but first let's go to the wasp nest material. So just by looking at that wasp nest, even as a kid, I was like, this kind of looks like paper. And the reality is it basically is. There's people say that it's like a paper mache type thing. But basically, the way they make their nest is they chew up dry or rotting wood, and they chew it up in their mouth, and then with the saliva spit it back out. and creates a paper mache type thing. Now, that's not how we make paper, but we take paper, we shred it, or we take wood, we shred it up into cellulose fibers, and then we mix it with water and other stuff, and then we let it dry, and it forms a fiber mat. So it's just wood fiber and water. So, I mean, you could technically call this a paper. So we'll zoom in to about 1000x. Let me focus. I can't remember if we looked into paper before. I know we looked at textiles. Correct me if I'm wrong, but I've looked at a lot of paper before in SEMs because of the College of Natural Resources here. They do a lot of research on paper and new processes for that. So I see a lot of paper, and this is actually, I don't know, you could, even if you told me this was a wasp nest, I would probably just, my first guess would be, this is some type of paper. And especially right here, this little part that has holes in it, that's kind of the husk of the cellulose. And you see that a lot with cellulose, and these fibers just look very, very small. So we're at 400x magnification. The scale bar here is 1000 microns. So just one of these fibers is about 10 microns in diameter, at least these ones right here that I've got my little cursor over. So who knew wasps were into microtechnology? And there's probably some nanofibers of cellulose in there. But yeah, now this is different from how bees make their nest, where they make it out of a sticky kind of wax substance. I was going to try to look over here too. I have no clue what this is. Zoom out. But yeah, it's crazy looking at these things at a higher magnification with an SEM. I'm always thankful when people send me samples, because normally people that aren't in science and engineering, when they send me samples, they send me stuff I've never seen before. So this is really cool. All right, so let's go back to fast. All right, so full disclosure, when I was pulling him out when I was pulling the wasp out of the nest, he did lose his head. And so his head is on one part of the stub, and then his body is on the rest. And so what we're going to look at is his actual head first. Now, I'm pretty sure this is a yellow jacket, just based on the color and the shape of what it was before I took it out. But there are like 9 different kinds, or there's all kinds of different wasps. And I just think yellow jackets are more common in this area. So I would guess that that's what this is. So we're just looking at his head, just looking kind of top down if someone was looking at the top of your head. And we're at pretty low magnification right now. We're at about 25x. And so you can see, or if you can't tell, his mouth is over here. And then this is kind of the top of his head, which I think they call the vertex. And then we can see his little mandibles over here. He's got an eyeball here, an eyeball here. You see these 2 holes, that's where his antenna go. And then there's some things over here. But first, let's go look at his regular eye, which, if you remember our fly episode, you know what we call this kind of eye. All right, so stick right here. Let's go and make this a little bit brighter, and then start going slow. All right, so if you remember from the fly episode, we talked about his compound eye. So almost all insects, or many insects, have compound eyes, where instead of where we have like periscopic eye, which can look multiple directions, they have a compound eye which has hundreds of single eyes that can look in one direction, and their brain generates that into a 3D image of, or an understanding of what's around them. So a lot of bugs use this, and let's zoom in a little bit more. Let's see if I can get the focus really nice. Now his eye's dirty, so go ahead and start taking a guess of what these particles might be, because I think I see them all around. Now from me looking into wasps, apparently there are social wasps and solitary wasps, which is a lot like people. You're either introverted or extroverted. Um, and then there are some that live in they're called aerial habitated wasps, which I think is exactly what this one was. So if you see a wasp nest hanging from a ceiling, they're called an aerial nesting wasp. But there are ground nesting wasps, which kind of are in the ground, and they have a very large nest underground. There can be big ones in the air on the trees, but apparently this was an air nesting one. So I just think this is crazy. I mean, nature is beautiful. Just seeing the shape of his eye from this, and it's almost like a hexagonal structure. And I want to say that these little particles that we're seeing on him are pollen, and that now wasps aren't usually thought of as pollinators, but there are some that do contribute to pollination. It's not their key motive in life, or it's not one of the big things. No one's saying save the wasps, but they are important creatures. All right, let's look at the top of his fuzzy head. And let's drive over to his antenna. And let's readjust the brightness here. All right, so we're gonna go slow. All right, so when it gets to the antenna, so obviously his antenna is not there, and I don't know if it fell out of natural causes or if it fell out when I was preparing him. I don't think he had him when I got him, but the antenna is basically a giant probe that goes into a massive sensor, and even the hairs that he has going around it are helping him sense the world around him, and will also catch pollen and things. All right. I'm not sure what this is. This just looks like a bunch more pollen, a lot more pollen. Let's go slow. So whether he wanted to or not, I think he was a pollinator, because otherwise I don't see how he would have this much of what I would think is pollen. I think it looks like pine pollen. I'm not sure. I'd have to go back to our pollen episode. Go check our pollen episode and see which one this is. We may have not gone over it. We have more pollen though. So that's just so cool to me. All right, we'll keep moving on. Let's go over to this side of his head. All right, so this was pretty surprising to me. I had not known this before, but in addition to the compound eyes, wasps and some other insects have something called ocelli, O-C-E-L-L-I. Now on a wasp, these are usually 3 little individual bumps, which serve as the opposite of a compound eye is a simple eye. So it's still an eye, but they don't actually work together as far as I know, but they're meant to just be a basic sensor or detector of light or movement. So they can react quickly if their compound eye can't see it otherwise. So it's just crazy to me to see those. I never, when I looked it up, I looked up pictures of wasps before putting them in SEM. You can see these on yellow jackets. They usually look like just 3 black dots, but I'd never noticed them before. So thank you for sending the wasp in so I could see it. And it looks like, they're very smooth, and he's got some pollen there. He apparently didn't shower ever. All right. So we'll move off from that. And let's go to his mouth. Okay, getting a little bit focused. Let's stick right here. All right, so this is his mandible, which is his mouth, and it's a lot like other insects where the mandible's got these large claws which can crush or cut things that they're trying to eat. The way wasps feed their young or make their nest is they eat the food or chew up wood fiber and then mix it up and then spit it back out. So they need these big mandibles to help them cut things. And I think what we can't see is that wasps do have a proboscis which can come out and help them get nectar out of flowers. or other things. They may attack your hummingbird feeder too. So it just looks vicious. If I saw something life-size like this with a mouth like that, I'd be pretty scared. All right, just to give you an idea, we're only at 180x, but we're seeing a lot of these details on these other little hairs that he's got sticking out. So he looks pretty vicious. So yeah, you see those are very sharp. Those would hurt. All right, so we'll move away from the head. And now we're gonna go over to the rest of his body. I'm gonna go and check the chat, make sure, yes, we did look at paper. Pine pollen's much, much bigger, thank you. And Kristen Fields says that it is likely a she. Most in the nest will be female. Apparently the males are unable to sing. Thank you for sharing. The way they're born is they actually start as larvae in each of these little cells, and then they grow out they feed the larva digested food or regurgitated food into the holes, and they come out. But this one looked a lot, or too big. Obviously, it's too not larva, but I think they do come back to the nest afterwards to sleep at night while others guard watch. So let's back out. I'm gonna fix the brightness, and then we're gonna just take a low magnification picture of its body. All right, so let's go and go slow. All right, so there's all kinds of different, I saw different diagrams of what wasp bodies are, but this would be what I guess is their thorax, which is the middle part, and then its abdomen is down here. One of the key differences that you can tell between a wasp and a bee is that, bumblebees or honeybees are usually a little bit fatter and fuzzier, whereas wasps have a kind of a longer body, and they almost have like a very slender waistline. So they, I guess they look more athletic. So let's go look at his her wings. All right. So that looks very cool. It's a very big wing. I feel like I've always noticed that wasps have like really long but skinny wings. Even on their wing, they have different hairs on it. And we're at 150x, only at 300 microns scale bar. That's a cool image. Let's go over to the thorax. Or actually, let's look at the kind of joint where the wing goes into the thorax. All right, let's go slow. So this is only 60x, but it's a very cool image of what I would guess be it's similar, or just where the wing goes in. So it's almost like a shoulder. We see other kinds of stuff in here. So who knows what all this stuff is? He or she was probably just sleeping when they passed of natural causes, or someone spraying it. We don't like wasps generally as people because they seem to be more aggressive. And apparently the reason why that is because at the end of their life, basically they're retired and all they want to do is eat sweet stuff. And so when they feel like they've done their job, they just go out looking for something sweet to eat. And that's why we probably have all had a bad experience of having an ice cream cone or being out eating outside and having a sweet treat, and a wasp is just bugging you trying to get a piece of it. They just have nothing to do when they're retired other than just find sweet food. There was a story that I found about a problem with wasps in England where they were eating a bunch of fermented fruit. So they were pretty much just getting intoxicated and eating sweet stuff all day, which would probably be a good retirement. All right, let's try to look at the feet real quick. Now, if you remember the fly foot, well, I don't know if we actually looked at the this part of the fly, but on fly feet that I've seen before, they have like these kind of like two balls at the end. So big difference here is that it kind of just looks like a almost looks like a hoof. But we're at 200x magnification. The scale bar down here is 200 microns. So again, these little hairs coming out are about 100 or 10 microns or so, maybe 10 to 50 microns. So that's cool. And then I guess these would technically be its feet, and then this is still part of the legs. These things sticking out, you could either call them toes or feet. Very cool. So I don't think we can get a shot of the stinger. I am not sure if this is the actual stinger, but we're going to go take a look at it anyways to wrap it up here, because the stinger's the part that is the last thing we'd ever want from a wasp. And again, he's got a bunch of this stuff all over him. So yeah, there's this thing coming out, and I feel like I've seen this come out of other insects before, but I'm not sure if it's, I've heard that some stingers can, if like some wasps can sting you and then they end up dying from it because it pulls out everything that's inside them. And I don't know if that's necessarily what we're looking at here, but something happened towards the end of his life, something that's sticking out of the back end there. And I was not able to determine what exactly that is. There's not a lot of information or that I could find about just looking at wasps under SEM. So actually on all of these, most people are looking at very specific things in an optical microscope. We don't usually just do a general, like, here's this thing, let's just look all over it, see what it's like. So we're doing some groundbreaking science right now, some exclusive images that are very fun to look at. So we'll wrap up with this. I want to say thank you to everyone who sent me samples. I hope you got a nice good look at it, at these samples with the SEM. I really enjoyed doing it. I'll back out a little bit and we'll just let it hang on the wasp for a little bit. And I'll pull up the camera back so that I can see everyone, and I'll check the chat one more time. But go ahead and ask questions, or let me know if there's something you want to look at more. And I've got enough time till 1 to keep looking. So thank you all for tuning in. And if you leave, thank you for joining. Thank you, Kristen, for tuning in. And thank you, Holly, for helping in the background this time. Thank you, Carl, for tuning in.